An alien skeleton. Their skeletons are unlike anything else in the animal kingdom. Instead of long bones or solid shells, they build from within, assembling thousands of microscopic crystals called ossicles. Each ossicle is made of magnesium calcite, a mineral that resists dissolution even in acidic waters. It is as if their bodies are filled with millions of living jewelers, crafting a lattice of armor from sparkling shards. These ossicles lock together in ways that seem to defy design. In brittle stars, they create flexible joints, like a chain of armored vertebrae. In sea urchins, the ossicles fuse into a flawless dome called a test, perfectly engineered to withstand the crushing forces of waves and predators. And in sea cucumbers, they are tiny and scattered, leaving the animal soft, gelatinous, and disturbingly boneless. But the skeleton is not hidden. It sprouts outward into spines, spikes, and in some species, bizarre snapping jaws called pedicellariae. To the casual beachcomber, they look ornamental, delicate flowers blooming across a sea star's skin. But under a microscope, they transform into nightmarish machines, three-part forceps that seize, slice, and sometimes inject venom. They scrape away algae, clean parasites from the body, and when provoked, can close on an intruder like a field of microscopic bear traps. The water vascular miracle. Beneath their armored skin lies a system so strange it seems more mechanical than biological, the water vascular system. At the heart of it is the madreporite, a calcified valve that filters seawater into a labyrinth of canals. From there, pressure flows outward into hundreds of tube feet, soft, muscular cylinders tipped with suction cups. Each foot can inflate, grip, and retract with astonishing precision, all controlled by water hydraulics. With this system, a sea star can crawl, climb, or cling to rocks against pounding waves. A giant sunflower star, with over 2,000 tube feet, can sweep across the seabed like a living carpet, surging faster than prey can escape. When hunting clams, dozens of tube feet act as winches, pulling steadily for hours, even days, until the shell gapes just wide enough. Then comes the horror. The sea star everts its stomach, sliding it inside the victim's shell, digesting the clam alive before pulling the stomach back in. A slow-motion execution, perfected over 450 million years. Vision without eyes, motion without a head. Sea stars have no brain, no head, no central command center. Instead, a nerve ring encircles the body, linking the arms in a distributed network, more like the internet than a vertebrate brain. Each arm can move semi-independently, making decisions without permission from the rest. Yet they see. At the tip of every arm is a rudimentary eye, a cluster of light-sensitive cells. Alone, each eye is crude, sensing only shadow and light. Together, 5 or 20 in some species, combine into a panoramic visual field, nearly 360 degrees. Some species even grow darkened pigments on their tube feet, acting like natural sunglasses to reduce glare in shallow waters. And then there are brittle stars. Restless, quick, they abandon tube feet for speed. With whip-like arms, they row across the seabed like frantic swimmers. To turn, they simply elect a new arm as the front. To flee, they scatter like shattered glass, each piece darting away in disarray. Relatives in disguise. The echinoderms come in many forms, each stranger than the last. Sea urchins wear their skeletons on the outside, bristling with spines and equipped with one of evolution's most fearsome chewing devices, Aristotle's lantern. 5 interlocking teeth that sharpen themselves as they grind, capable of scraping rock and slicing flesh. Sand dollars flatten themselves into coin-like discs, burrowing under sand, leaving only tiny spines waving above the surface to filter plankton. Feather stars, delicate and ethereal, drift like Gothic chandeliers, waving feathery arms through currents. Their cousins, the ancient sea lilies, still anchor themselves with stalks, standing tall like eerie underwater flowers. Some feather stars can swim, rowing gracefully with their arms, rising from the seabed like enchanted ballerinas before sinking again to feed. But predators lurk. Sea urchins devour crinoids with relentless jaws. In defense, feather stars can sever their own arms, sacrificing limbs to escape, then regenerate them later. Alchemy of flesh. Perhaps their most astonishing trick is their mastery of mutable collagenous tissue. Their bodies can harden into armor or melt into jelly within seconds. With this power, a sea star can squeeze through the narrowest crack, then lock itself rigidly in place to resist predators. If caught, it can shed an arm entirely. The detached limb crawls independently for hours, distracting the attacker while the star escapes. The wound closes within minutes, and over weeks or months, the arm regrows, complete with nerves, skeleton, and tube feet. In some species, a single severed arm can regenerate into an entirely new individual. This power to reprogram cells back into stem-like states has fascinated scientists. If we could learn their secrets, medicine might one day regrow lost limbs in humans. The endless cycle. Reproduction is as diverse as their forms. Some sea stars clone themselves by splitting in half, each piece regrowing the missing parts. Others release millions of eggs and sperm into the sea, relying on chance and currents for union. Some brood their young under their arms, carrying them like living incubators until they are ready to crawl free. And in bizarre cases, the young eat each other inside the parent's body, until only one survivor bursts forth, already a killer. But always, the story begins the same. A bilateral larva drifts in the plankton, ordinary and symmetrical, until the second larva awakens inside, devours the first, and takes its place. Evolution's strangest rebirth plays out, again and again. The alien among us. The sea star is more than an animal. It is a living paradox, brainless, yet aware, boneless, yet armored, fragile, yet indestructible. It has endured 5 mass extinctions, outlived empires of life, and spread across every ocean on Earth, from tropical reefs to the darkest abysses. Beneath the waves, they crawl, glide, and climb, as they have for 500 million years, reminders that evolution's imagination is far stranger than our own. And as they wink their starlit eyes from the seafloor, we are left with a thought. Perhaps we are not the masters of design, but apprentices, still learning from creatures that look like they fell from the night sky into the sea. Sea stars, architects of alien evolution. In the vast history of life on Earth, before the first forests rose, before mammals took their first tentative steps, long before birds conquered the skies, a stranger lineage was forming in the ancient seas. The ancestors of sea stars had a curious ambition. They abandoned the straight, balanced body plan shared by nearly every creature on Earth. Evolution whispered a different design. Forget symmetry, become a circle. But the transformation was no simple matter. Their young began life looking like ordinary bilateral larvae, little more than translucent tadpoles drifting with the currents. Then came the coup. Inside their fragile bodies, a second larva began to grow, rounder, stranger, more alien. It consumed its host from within, replacing it entirely. Out of this act of biological cannibalism emerged something Earth had never seen before: radial symmetry. 5 arms radiating from a central hub. A living star born from betrayal. Thus began the age of the echinoderms, the spiny-skinned ones. Sea stars, sea urchins, brittle stars, sand dollars, feather stars, sea cucumbers, all heirs of that monstrous rebirth.